Assalamualaikum students, hoping you all fine. I am Asma and I am with you with the 5th program of calculus of BSCS level. This program is about lines, parabola, ellipse and hyperbola. But before going to today's program, let me briefly explain that what we have studied in our last program. In our last program, we studied coordinate planes, Cartesian coordinate system and its drawing, sketch the graphs of lines, curves, etc. and analyze the symmetry concept in graphs. As I told you that today's program is about lines, parabola, ellipse and hyperbola, so after the end of the program, it's expected that you would be able to define lines, slope of a line, parallel and perpendicular lines, parabola, ellipse, hyperbola and some important properties and graphs of parabola, ellipse and hyperbola. First of all, we shall move to line. In this section, we will discuss to measure the steepness or slope of a line in the plane. The idea we develop here will be important when we discuss equations and graphs. First of all, we will define slope of a hill. And slope of a hill is defined to be the ratio of its rise to its run. You can see a figure to explain the slope on the screen. As I told you that slope is the ratio of rise and run. If we consider a hill and a run of 20 feet and a rise of 2 feet, then the slope of a hill or this line would be equal to rise divided by run, where rise is equal to 2 feet and run is equal to 20 feet. So finally, the slope would be 1 divided by 10. To explain slope more properly, you can see another figure on the screen. Let's consider a particle which is moving from P1 to P2, where slope is equal to again rise divided by run, and the notation for slope would be used as m. And if we say that run is change in x, which is x2 minus x1, and rise is change in y, which is y2 minus y1, then the slope from point P1 to point P2 would be equal to y2 minus y1 divided by x2 minus x1. Means slope of a line always remains the same even if the points changes. Now we will define slope of a line through 2 points. You can see a figure on the screen. If we have a line having 2 points, which is P1 and P2, P1 is having points like x1 and y1 and P2 is having points x2 and y2. Then the slope for these 2 points would be y2 minus y1 divided by x2 minus x1. If on the same line we consider 2 different points, which are P1 dash and P2 dash. P1 dash is having points x1 dash and y1 dash, and P2 dash is having points x2 dash and y2 dash. So finally, the slope would be y2 dash minus y1 dash divided by x2 dash minus x1 dash, which would be again same as the previous slope, which is y2 minus y1 divided by x2 minus x1. Dear students, now we will explain slope with the help of some numerical examples. You can see some examples on the screen. As in first example, we have to find a slope of points 6, 2 and 9, 8. For the solution of this example, we will use the slope formula, which is m is equal to y2 minus y1 divided by x2 minus x1. So 6 divided by 3 would give you 2, means the slope for these 2 points would be equal to 2. Now we will consider one more example to understand slope, where the slope value would be negative. You can see that example on the screen. For this example, we have to find the slope of points 2, 9 and 4, 3. Again, for the solution, we will be using the slope formula, which is m is equal to y2 minus y1 divided by x2 minus x1. For these points, x1 is equal to 2, y1 is equal to 9, x2 is equal to 4 and y2 is equal to 3. So the final slope would be equal to -3. We can consider one more example to explain slope, where slope would be equal to 0. You can see that example on the screen. For this example, we have to find the slope of points -2, 7 and 5, 7. By putting all these values in slope formula, we get 7 minus 7 divided by 5 minus -2. So the slope for these 2 points would be 0. There exist different slopes for different lines. Now we will explain some different slopes for different lines through a figure. You can see that figure on the screen. You can see a Cartesian plane over here, which is having 4 quadrants, first, second, third and fourth. In the first quadrant, all the lines are having positive slopes. In the second quadrant, all the lines would be having negative slopes. The line which is parallel to x-axis, or which is the line of x-axis, over there slope would be always equal to 0. If we consider another line in the first quadrant for which slope is equal to 1/2, if we consider another line, slope for that line would be equal to 1, and the same diagonal line or the symmetrical line in the second quadrant would be having slope equal to -1. If we consider the third line in the first quadrant, which is having slope is equal to 2, and if we consider another symmetric line in the second quadrant, for that slope would be equal to -2. And again for another line, m would be equal to 3, or slope would be equal to 3, and for the same symmetric line or symmetrical line in the second quadrant, the slope would be equal to -3. As I told you that there exist different slopes for different points or different lines, so now we will explain some different types of slopes. First of all, we will see that what would be the type of slope for parallel lines. You can see a figure on the screen to understand slope of parallel lines. If we have two parallel lines, L1 having angle as phi 1 and L2 as second line having angle phi 2, then the slope would be same. Means even if we consider some points on first line and calculate slope, and if we consider some points on second line which is L2 and calculate slope, so the slope for first line which is m1 and slope for second line which is m2, both would give you the same value or the same number. Now the second type of slope would exist in second type of lines which are perpendicular lines. You can see a figure to understand the slope of perpendicular lines on the screen. Here you can see a line L1 which is having an angle of Q1 and a second line having an angle of Q2. These both lines are perpendicular. If we consider slope of first line as m1 and if we calculate the slope of second line as m2, then these lines would be considered as perpendicular if the product of their slope would be equal to -1. As we have studied slope and some numerical examples to calculate slope of a line, now we will study some methods to determine a line. You can see the first method of determining a line through a point and slope on the screen. The first method of determining a line is to determine a line by point and slope. We have studied the formula for slope, which is y minus y1 divided by x minus x1, and if we consider point as x1 and y1, then the line equation or line determined by point and slope would be equal to y minus y1 is equal to m into x minus x1, which is the point slope form of a line. You can better understand the point slope form of a line with the help of a numerical example which is on the screen. For this example, we have to find point slope form of a line through the point which is 4 minus 3 and with the slope 5. For the solution of this equation, we will be using the previous formula, which is y minus y1 is equal to m into x minus x1. For this case, we have x1 is equal to 4 and y1 is equal to -3 and slope is equal to 5. By putting all these values in this line equation, we would be having y minus minus 3 is equal to 5 times x minus 4. So finally the point slope form of a line would be equal to y plus 3 is equal to 5 into x minus 4. The second method of determining a line is to determine a line by slope and y-intercept. You can see the formula for line determined by slope and y-intercept on the screen. Line determined by slope and y-intercept is y is equal to mx plus b, where this m is the notation for slope and b is the notation for y-intercept. To understand this more clearly, you can see an example on the screen. We have an example if slope is minus 9 and line crosses y-axis at the point 0, minus 4. Then we have to determine the line. For the solution of this example, y is equal to mx plus b. We have given slope as minus 9 and y-intercept as minus 4. By putting all these values in this equation, we get y is equal to minus 9x minus 4. Through the table on the screen, we can better understand the equations which are determined by slope and y-intercept. If we have an equation y is equal to 3x plus 7, for this equation slope is equal to 3 and y-intercept, which is b, is equal to 7. For the second equation y is equal to minus x plus 1 by 2, slope for this equation is minus 1 and y-intercept, which is b, is equal to 1 by 2. For the third equation y is equal to x, for this equation slope is equal to 1 and y-intercept, which is b, is equal to 0. Next equation is y is equal to under root 2x minus 8. For this equation our slope is under root 2 and your y-intercept, which is b, is equal to minus 8. For the final equation y is equal to 2, slope for this equation is 0 and y-intercept is equal to 2. The third method to determine a line is to determine a line through a general equation. You can see the general equation of a line on the screen. General equation of a line is ax plus by plus c is equal to 0, where a, b, c are constant. And this equation is called a first degree equation or a linear equation. General equation of a line is explained through the help of an example which is on the screen. For an example, we are given a is equal to 3, b is equal to minus 4 and c is equal to 12. For these intercepts, if we draw a line, so a point on y-axis would be 0 and 3 and a point on x-axis would be equal to minus 4 and 0. You know the general equation of a line is ax plus by plus c is equal to 0. By putting the value of a, b and c, the final form of a general equation would be equal to 3x minus 4y plus 12 is equal to 0. Dear students, now we move to the second part or the second topic of today's program, which is about conic sections. You can see some types of conic section on the screen. Conic section consists circle, parabola, hyperbola and ellipse. We have explained circle in our last program, so here we will start with the explanation of parabola. You can see the definition and figure of parabola on the screen. Parabola. Parabola is set of all the points P in the plane that are equidistant from a fixed line and a fixed point in the curve. You can see the figure of parabola. Here, if the distance between S and P is equal to P and M, so it would become an equation of parabola. For an explanation of the equation of parabola, we can consider PS, or the distance between P and S, is equal to distance between P and M. For the P, we are having points X and Y. For S, we are having points A and 0. So by using distance formula which we studied in our last program, on the left hand side we have x minus a whole square plus y square is equal to, on the right hand side, x plus a whole square. So the final equation of parabola become y square is equal to 4ax. Parabola can be of different types. You can see 4 standard types of parabola on the screen. The first form of parabola is when directrix is negative and on the left hand side, and the curve or the parabola lies in first and fourth quadrant. The second form of the parabola is when directrix is positive and on the right hand side of the x-axis, then parabola lies in second and third quadrant, having focus negative with x-intercept. The third type of parabola is in upper half plane or in first and third quadrant, where the directrix would be negative with y-intercept. The fourth standard form of parabola is when directrix is positive and your parabola lies in third and fourth quadrant or in lower half plane. You can see the definition and figure of ellipse on the screen. Ellipse is the set of all the points in the plane that the sum of whose distances from two fixed points is a constant. Ellipse is always having an oval shape. In this figure, A1 and A2 would become the directrix, F1 and F2 would become the focus. By definition here, if the distance between F1 and a point on ellipse and the distance between F2 and a point on an ellipse is constant, then it would be a curve or it would be a figure of an ellipse. You can see the derivation of ellipse or equation of ellipse through the definition on the screen. If we have this figure as an ellipse, then by definition the distance between P and F1 plus the distance between P and F2 would be equal to a constant or would be equal to 2a. Now by distance formula, Pf1 would be equal to x plus c whole square plus y minus 0 whole square under the root plus the distance between P and F2 would be equal to x plus c whole square plus y minus 0 whole square under the root. And on the right hand side we have the same number, which is 2a. By simplification, we would be having cx plus a square is equal to a times under the root x plus c whole square plus y square. Now by more simplification, on the left hand side we have x square divided by a square plus y square divided by a square minus c square is equal to 1. If we consider b square is equal to a square minus c square, so the final equation for ellipse become x square divided by a square plus y square divided by b square is equal to 1. As I told you that there are different forms for parabola, so there exist two standard forms for ellipse. You can see these two forms on the screen. For the first type of ellipse, we have the equation x minus h whole square divided by a square plus y minus k whole square divided by b square is equal to 1. For this ellipse type, your origin would be at h and k and your major axis would be x-axis. For the second type, your major axis would be y-axis and again your origin is at h and k. For the second type of ellipse, you have the equation y minus h whole square divided by a square plus x minus k whole square divided by b square is equal to 1. For the second type, your major axis would be y-axis and again your origin is at h and k. If your origin is at 0 and 0, so the first type of ellipse equation become x square divided by a square plus y square divided by b square, where h and k would be equal to 0. And if we consider for the second type origin at 0, so the second type of ellipse would be having an equation y square divided by a square plus x square divided by b square, where again h and k would be equal to 0. The third type of conic or conic section is hyperbola. You can see the definition and figure of hyperbola on the screen. Hyperbola is the set of all the points in the plane, the difference of whose distances from two fixed points is a constant. This is the figure of hyperbola. Here you have two focus C and minus C, and if the distance between focus and a point on a hyperbola and from the second focus to the same point on the parabola is a constant or is equal to 2a, so then we would form a equation of hyperbola. Dear student, hope you understand and enjoyed today's program. Let me briefly explain that what we have studied in today's program as the summary. In today's program, we studied lines, slope of a line, parallel and perpendicular lines and their slopes, parabola, ellipse, hyperbola, which were the parts and the types of conic section, and some important properties and graphs of parabola, ellipse and hyperbola. Hopefully, I will join you in the next program with the concept of distance, circles and equations. Till that time, Allah Hafiz.